The day was September 1st, Labor Day, and I was over at my cousin's house, but since he was homeschooled, he had homework to do, so I did it with him, and he had math homework. So we asked his parents if instead of doing his math homework, we could make a calculator. And then they said yes, so we went ahead and did it. And before we get into this, you may be thinking Labor Day wasn't that long ago, and it's been a month since your last upload. I know, but I was working on the other video, and I just wasn't able to get it out in time because I got too distracted with optimization. So you're getting this video instead. The point is, okay, we start working on this calculator, and we add the simple functions first. We get the calculator up and running, which we actually had to create a third thread to run it because of how my engine works. Because we didn't have enough time to make it graphical, so it had to be run in the terminal and stuff. It's a little complicated. The point is we had to run in a separate thread, and then we got the basic functions working like addition, multiplication, subtraction, and the weird percent symbol. Um, and then we got, we were we were looking at the Google calculator for ideas to add to our calculator. We added square rooting and um, and then we saw this button and we're like, what does this button do? So we did 335 and then clicked that button and it said infinity and we were instantly intrigued. So we looked it up, and apparently that's the factorial button. And what a factorial is it takes a number and then multiplies it by the number lower than it over and over and over again. So if you had like 20, it would multiply it by 19, then 18, then 17, then 16, then 15. So it gets really large extremely quickly. And so we did some testing with the Google calculator, and it could calculate factorials up to 170, which had like 305 zeros at the end. So we're like, wow, this is cool. So we tried to implement it into my engine in the math.hpp file, and we ran into some issues really quickly because we were using integers, and they could not store numbers as high as factorials go. Like, it could do like 5. I mean, obviously, it could do 5 factorial since that's just 120, but it was like struggling with like 10 factorial, I think. I can't exactly remember how far integers got. The point is, integers, they weren't doing it for us. Um, and I knew deep down a uint 64 wasn't gonna do us good either because it just factorials just get so large extremely quickly. So our next solution was to install a third-party dependency to calculate factorials. So we browsed the web for a little bit, and eventually we asked AI to find us some third-party dependencies to calculate factorials for us, and it found a couple. The problem is they weren't single headers like my audio or my texture or my font rendering, which I actually the font's a story for another time. The point is, okay, they were not single header. They were like hundreds of megabytes. Like it was like an all interconnected like entire like library. But I just wanted a single like file or something. I didn't need like all their intense features that they required. I just wanted some file. So third-party dependencies they didn't work out. So I asked Grok to make a file that would automatically calculate the factorials for us. But its solution was to straight up create a new variable called the uint 128 underscore t, and we were instantly intrigued. We were searching for like 45 minutes. The point is we were tired of searching for these dependencies and we're like, okay, I guess we'll just use our custom variable now. And up until this point, I was like, I'm not going to create a custom variable because I've seen what code it takes. And this uint 128 underscore t, I don't know what the underscore t is for, but the point is, it was hundreds of lines of code. And so we spent like a good like 20, 10, 20 minutes, I don't know how long it took, bug fixing it, but eventually we got it working. and it still couldn't calculate good factorials. It was like calculating like in the 20s or the 30s, maybe the 40s. I don't know exactly how far it went. The point is, it wasn't accurate, and we noticed it wasn't accurate because there wasn't a whole bunch of trailing zeros at the end of the numbers it was outputting. So we asked ChatGPT to see if it was the correct number, and sure enough, it wasn't, and we were so confused. Turns out the uint 128 it just wasn't big enough to store factorials, so we we made the uint 256 underscore t, and it got much further. It got to like the 60s or the 70s, I think, but again, it wasn't beating the Google calculator, and we knew from this point onwards that our mission was to beat the Google calculator. So we generated more variables. We generated the uint 512 underscore t, and it got to like the like 130s or 140s, or maybe the 110s or 20s. I actually can't exactly remember how far these ones went. The point is, once we generated the uint 1024, it got to exactly 170. And then at 171, it ran out of memory and started outputting a whole bunch of junk. So we figured out how big of numbers the Google calculator calculates with. It calculates with 1024s, one uint 1024s. So our mission wasn't just to match the Google calculator, it was to beat it. So we generated the uint 2048 and the uint 4096 just for fun. And we were burning out at this point. We were making these variables for like 2 or 3 hours. Well, technically we were asking AI to make them, but we had to bug fix a lot. So, um, well, we asked AI to bug fix it too. The point is, okay, we were generating these variables, and we generated one more, the uint 8192, I think it was, and we were done for the day. It could calculate factorials up to like 400 accurately, at least. So it was big enough for our needs. And um, I woke up the next morning, and I was like, it's slow. Like it was intensely slow. The Google calculator, we could calculate past it, but we sure couldn't calculate as fast as it. Because the Google calculator, it gives you like the number instantly, and ours did not. Ours waited like 10, 15 seconds to generate just like 400s on a decent computer. So, I optimized it. I optimized the factorial code, and I optimized the multiplication code, and and the addition code and subtraction code. I optimized all the code, and all of a sudden, instant responses on 500 and below factorials. Anybody wondering, 500 and below? I thought the max was 400. Well, it was actually a little more than 400, and also I generated the uint 16,000. Actually, I need to check exactly what it was. Alright, it was the uint 16,384 underscore t, and for fun, I generated the uint 32,768 underscore t, and I also made the uint 65,536 underscore t, just so that I could reach past the 2000 lines of code mark, because before the optimization it was 2012 lines of code, but after I optimized it, it went down to like 1560 something, I don't remember. Now it's back to 2211, so I'm happy with it, and also I get a ton of new variables. So it was an adventure. I thought it was worth talking about. It was kind of good.